Hello everyone and welcome to today's SANS webcast. Amcache rules everything around me. My name is Carol Auth of the SANS Institute and I will be moderating today's webcast. Today's featured speaker is Eric Zimmerman, Senior Director at Kroll Cybersecurity and Investigations and SANS Instructor in Training. If during the webcast you have any questions for Eric, please enter them into the questions window located on the GoToWebinar interface. We will be answering them during the Q&A session at the end of the presentation. And with that, I'd like to hand the webcast over to Eric.
Hello everyone. Thanks for attending today. Today we'll be talking about Amcache, what it is, how it works, the different parts, and not only that, but because of how things are interrelated, how we can leverage that to our advantage when it comes to investigations to be able to reduce the amount of data that we have to look at to try and make some conclusions. So we'll have a few different topics of discussions. The two main ones are what is it? The second one will be the various parsers that are out there. We'll talk about a Python parser and we'll talk about my parser. The first two things we want to talk about though are what it is, what it can tell us, and then get an understanding of how data is stored in the various places inside the registry hive so that we can use any tool that we want that understands how to deal with the registry, do validation of tools and so on, and then we'll drill down into actually how to automate extracting out a lot of that detail so that we can make use of it. So what it is, this is just, I'm not going to read all these verbatim, but basically it's a registry hive. It lives in the Windows AppCompat programs directory. The file that we are interested in is amcache.py, and the nice thing about it is it's just a registry hive, so it's going to act like any other registry hive you are familiar with as far as the structures and the ability for tools to process it and those kind of things. So we have a multitude of ways to interact with it. Now Amcache is basically a replacement. It supersedes the recent file cache that came about in Windows 8. But the nice thing about Amcache is it has significantly more detail, including the full path, multiple dates and times. We can also glean other information as far as when things first happened based on when things ended up in the registry hive. So there's a lot more detail up to and including the SHA-1 of the binary that was executed. In addition to files that are executed, it also keeps track of all the files that get copied to a machine when you use an installer like an MSI file or an executable file, for example, to install Office or a game or any other thing that you're used to installing. Amcache will keep a list of the installer and the metadata about the installer, so what the installer was for, who made the installer, publisher details, those kind of things, as well as then all of the files that were placed on the machine, including the full path, and all those kind of things. So we have that. Basically, these files exist on the machine now, and then we also have programs that were executed. And as you'll see as we go through this, there's a means that we can take the data from the programs and then relate it back to the information that is tracked on the files and really whittle down what we need to look at. And the bottom line is what we're interested in when it comes to Amcache is primarily to show evidence of execution of anything. We're interested in executables or any kind of programs that would run that may drop malware or anything else on the box. We want to know that. What kind of stuff can it tell us? We've talked a little bit about some of these already, but we're interested in the SHA-1, the size, and I mentioned depending on where the file came from, we could either reference the product or in some cases it's in the file data itself. And then we also have several different timestamps. So, and these might be epoch time, these might be 64-bit file times. So we have to interpret them differently. Once we do, we have a bunch of nice dates that we can use for timelining or whatever other purpose we're interested in. So how does it work? I mean, everybody that's seen results from a parser, we have all this data. How does it interrelate? How do we understand moving from the file records down to the programs records? There's a lot of moving pieces, and it could be overwhelming just to run a tool and then you get this output. How does it all get put together? That's what we want to understand first, so that once we have an understanding of how the structure of the data works, then we'll have a better understanding of what our tools are doing in order to be able to speak to how we got results, to be able to validate the tools that we're using, and also, and this is really important, as new versions of operating systems come out or service releases, we want to be able to do new research to find new artifacts that will help our case, and having an understanding of the data will allow us to do that, not only to make sure that our existing tools work, but to be able to add new features to the tools so that we have even more information going forward. So as I mentioned, Amcache is just a registry hive. So this is a registry hive, Amcache hive from a Windows 10 system, and I loaded it into Registry Explorer. And you can see in the upper left we have our hive name, and then it looks like any other registry hive that you've ever looked at in different places. We have our keys and subkeys on the left, and when we click on a subkey, we have our values on the right. Same idea as far as deleted keys and values, we can recover those. We have Slack, we have all the nice stuff that we're accustomed to when we're dealing with registry hives. There's two primary things that we want to talk about, two primary sections. Even though, if I go back one second, you can see we have a root key, and then we have a device subkey, a file subkey, generic, HW item, metadata, and so forth. We are primarily interested in the file key and the programs key. That is where the bulk of our information is going to come from. So we're first going to speak to the programs keys and then the values that are inside of those. So this is just a little bit of a background. There's certainly a lot more information that's available in here, but for the purposes of this discussion, these are the ones that we want to try and hone in on. At the end of this presentation, I'll have a list of a lot of other references, including my own blogs, Swift Forensics blog that kind of starts unpacking and laying out what some of these values mean, and in both the programs and the file keys. So please go back and reference those if you're interested in even more details than what we'll get into today. But this is just an overview. We have our subkey names, and Swift Forensics did some research and was able to determine that the key names, and you'll see why those key names are important in the files. We want to figure out, if we can, how these things get named, because we may be able to pull more information out of them. So the program subkey names come from the MSI installation packages. I haven't delved too deeply into that to correlate anything like that or see if there's anything else that we could extract from that key. But from my understanding, looking at the research that's on the Swift Forensics post, it's basically like the signature of the MSI, and it's almost like a GUID. It just gets generated as far as when the package is made. And then underneath there, in each of the programs keys, we have several values of interest. And so this is just a short list. On the left side, we have the value name, and then on the right, we have a more usable description of why we would be interested in that particular value. So, for example, 0 might be Microsoft Office or Steam client or some other installer, the general package name that you'd be interested in. We have the version, who made it. Now those kind of things, the who made it, the to value, that might be important because now we could start looking at and pulling down the same installers to generate whitelists and do all kind of other means of things that we want to do, as we'll see going forward, to be able to eliminate a lot of the noise and other things that we have to deal with when we're looking at all of this data, because there's quite a lot of it on anything that a system that's been used even briefly. So D is a little bit different in that it's just a list of directories, so it's not just going to be a single entity, and we'll see what that looks like in a minute. And then there's also a files value, which is a list of files, and that will jump back up to the other key. It's a list of the file entries that this program references. I don't trust it 100%. I think it's better to basically reference the key names in both places, but it's certainly a valid secondary check. And the nice thing about it, as other examiners have mentioned on their blogs, I think Harlan mentioned this on one of his, we could take that list, and if we understand how the file entry names are created, we can break that up, and we have a lot more potential MFT entry number and sequence number information, as we'll see when we get to the file section. So this is a kind of a zoomed in view of what you will see if you click on one of the program's subkeys. And you can see here we've got this particular one that I'm on it starts with the, I'll skip all the zeros, 19B, it's bold, and we have 20 values in there. Not all of them have every value, but the majority of them will have at least 17, as you can see, and sometimes a few extra ones. So as you go down, you can see the zero keys, and we'll break this down in a minute, but on the next slide we'll get a better understanding. But you can see just how many different field or values are in there, and we could start pulling those apart. So here's just an example of the ones that we were interested in highlighted. So we have our ANTS performance install profiler, that would be our package name. There's our version. We have a couple of GUIDs, and then who made it, so where it came from, the vendor. So this, we could pull a lot of information out of this. As I mentioned earlier, we could take these and basically try and recreate. Maybe we want to try and recreate a current system on a VM or otherwise. We can do some testing and pull down these packages to have an understanding. We do the install, we see the effects, and so on. So there's a lot of things that we could do just based off of the programs alone to see what programs get installed and where, and the files that accompany it. So at the bottom you can see an example of what those file entries look like, and it's a lot, but you see we have a GUID, which is be our volume ID, and then we've got the @ sign, and we've got our file reference, which will make more sense when we get to the next section. They're just separated by a space, so we would have to get that and then split it apart, and we'd have to do a little bit more work to start understanding that, but it's certainly a nice back reference to understand all the files that this particular program placed on the machine. So basically now we want to switch gears and talk about our file entries. So you see we've now zoomed up at the bottom above the associated deleted records. You see the program, so we just move up and we're into the file key now. And directly underneath the subkeys of the file, you see we have GUIDs, and those GUIDs are the volume GUIDs. So there would be the same ones that we're familiar with, and you can see I've kind of clicked over into the mounted devices tab. You can see those GUIDs are going to line up with what we have there. So we can now basically say what drive letter these were on, and we could do the same with our MFT entries and sequence numbers that we'll see in a minute. But that's how those are grouped basically into buckets. So underneath the file key we'll have subkeys, and those are our buckets, basically where those files were placed or where they executed from. And once we start getting into the subkeys underneath the volume subkeys, we'll be able to see even more information about all the particular files. And then just as a side note, and we'll break a few of these down in a second, but that the subkeys underneath the volume GUIDs are, depending on the file system, that's how it's determined how they get created. So on an NTFS system, it's the entry number and sequence number, and for FAT, it's the offset to the directory. And we've seen type logic in shell items. So in Shellbags Explorer, we can determine file systems and all those kind of things as well. And then we can also, in this case, split those apart. In the shell items, for example, they're stored a little bit different, but it's the same type of logic as far as FAT, directory offset, NTFS, MFT entry, and sequence number. So this is just an example if you wanted to break some of those keys down manually to verify the tool or do new research, etc. So if we have our key entry, file entry key, for example, the 870000-1DE7D, basically we take the first 4 characters, clean it up a little bit, and that becomes our sequence number, and then the remaining characters are our entry number. So it's that simple. And then now we have not only, as you'll see in a minute, we have our file path and all the other stuff, the SHA. We also have our MFT entry number and sequence number to be able to go back to, let's say, a forensic image and validate that they're the same and all those kind of things. When it comes to non-NTFS systems, sometimes you will see values, the file entry key names that are too short. So if you are trying to apply logic to cut that data up, sometimes you'll run into problems. So the easiest way that I found is if it's less than 8, pad it out to 8 positions, and then you could start doing your normal logic. Everything else will just fall into place once you do that, and you start with 8 characters. And again, we're typically going to see that on the non-NTFS file systems. This is now drilling down into a concrete example. So here we have the same one we were just talking about. So we have our 870000-1DE7D, and we'll talk about the values in a moment. But basically now, I went and found that same path, and you could see the 15 value on the right side of the screen at the top points to an executable called scan2folder.exe. So in your forensics tool of choice, this screenshot in the lower left is Xways. I basically went to that file's file record, brought up the template, and you could see the information that we generated on the previous slide matches from our entry number and sequence number. So just as we did when we started talking about our programs, now we could start speaking and pulling apart all of the values in our file keys. So these are just some of the more interesting values that we would be interested in. So we have the 15 is our full path, and we just saw an example of that. 101 would be the SHA. And keep in mind, I don't know why they do it, but when you see the SHA values here in the registry as they exist natively, just to go look at them, they have an extra 4 zeros at the front. So you'll keep that in mind if you have an executable and you're generating a SHA. Of course, those aren't going to be there. So if you're going to do any kind of programmatic match, you're either going to have to strip those or do some kind of logic to handle the extra data at the front of those if you're pulling them out and just using them as is. Otherwise, just pull 4 zeros off and you'll be in good shape. 100 is the program ID. That would be the key name under the programs key that we talked about first that this file references. Then we have a last modified, the 11 and the 12. Those would be from the file system, and they're stored as 64-bit timestamps. So we could just reverse that back and we get our date and time like we do everywhere else. And then there's also file version information in there, and those sometimes they're more populated than others depending on how they got there. Same with our last bullet point there with PE headers and compile info. Sometimes it's there and sometimes it is not. This is, again, we're just drilling down into a particular example. So on the left side now you can see I've got several subkeys under file expanded. So that would correspond to the individual volumes where things were run from. And then this particular example, I have the 6C617 key expanded and then the 1000066 file entry highlighted. And you could see it's Xways portable, running off of a USB drive. So that would be, we could point that back using other means to tie that back to what actually the volume that it came from based on the volume GUID and all the other means that we have to cross-reference, which we'll see here in a moment, to do that. So this is just, you can see we talked about, what, 6 or so particular values, but there's a lot more in there as well. And the blog posts and either mine or on Swift Forensics and other resources will go into when they're known, what those other values are. Sometimes we get duplicated data or duplicate timestamps and things like that. So everything's not discussed in here, but again, if you're interested in those, the other values, please refer to the resources at the end to further drill into what data is available in here. Again, just like we did with our program entry, this is just an example broken down by the values of interest that we're going to be discussing today. So just grouped according to what we were already seeing. And the green there is the stuff at the bottom we'll talk about in a minute as well. Just grouped logically about what those things are. So I talked about this in the beginning, but the nice thing about the way Amcache works is when an installation happens, it's going to keep track of the program that did it and then all the files that get copied to it as a result of that installer running. And then not only do we get a file entry, but then it will be tied back using one of the values to one of those program entries. So it's nice in that we can then automate and start pulling those things out and apart and deduplicating and grouping things so that we have a much easier time looking at the volume of data that is generally available in Amcache. Okay, so the file entries, as I mentioned, they will end up in there in the file entry subkeys, but not always just from a program, right? If we just get a standalone executable and run it from the temp directory, we'll get an entry in there as well. And those are the ones that we're more interested in initially, is the stuff that came from outside of an installer. For example, it would be potentially more trusted. If we know Office is expected on this machine, I'm not as much concerned about the Office executables running than I am about other weirdly named executables running out of directories where executables aren't normally run. So those are the kind of things we will be able to drill down into, and having an understanding of what we've seen with the interrelation between programs and files, we'll be able to do that in a much easier manner. So at the end of our structure, this is what we have. We have basically two buckets, primary buckets. We have a list of programs and we have a list of file entries. And the file entries come in two types. Ones that we can associate back to a particular program. We know where it came from. And then we can also, based on if we take all of our file entries and then we can strip out all the ones that we know came from a program, we have what I've called unassociated, which means it ran, but we don't know what program put it there. So those are the two general high-level categories, and then the subcategories that we want to have an understanding of as we go forward. So as far as how do we want to use this data, when we get into our examples, you'll see there might be 20,000 bits of information. If we take all the programs and all the files, you might have 20,000 lines in a CSV file, for example, of files that ran, maybe they didn't, maybe they just came from an installer. We want to be able to narrow that down so that we can focus and potentially pivot around a lot more interesting executables than everything that's in Amcache, right? So that's what we want to try and understand and start narrowing down to. So just in general, my recommendation is that we want to focus in on those executables that came from an unknown source, right? Not an installer, I mentioned, like Office or anything else that might be in a corporate environment where we know what's typically on a system. We want to try and eliminate those so that we can get into the stuff that ran outside of normal. And that's going to be interesting, more interesting for us. Now, we may, for some reason, want to know everything that was installed on there, and so it's important to be able to get at that information, but we don't want to start consuming that necessarily in our timelines and just as a quick look initially, because it just is so much data, it's going to be a lot of noise. Let's see, we have a question here. Are there any known native Windows APIs or tools which would allow anti-forensics on Amcache? I'm not aware of any that I've seen. Because it's just a registry hive, it would not be difficult to write something that could do that. There's plenty of APIs out there that would do that, including the Windows API if you mount the registry hive. I've not done any testing on that, but I would think it would be relatively easy to do because of the multitude of registry tools and programs that are out there to do manipulation of hives. So not something that I've done any kind of in-depth look at, and I'm not aware of any. If anybody else is aware of any kind of anti-forensics or they've run into that where they've been able to determine that happened, please let us know in the chat, and we can make that information available to everybody else as well. Good question. Okay, so it's not just we have all these programs and file entries. That's all well and good, and we can look at full paths and SHAs and all these things, but we have other artifacts available that will let us tie their interesting artifact data back into Amcache. And so I'll show you a few examples of what we'll be talking about here, what we're talking about in the next couple of slides, and it really will help us further get an understanding of the particulars beyond what's available in Amcache. So for example, this is how we could take Amcache data and then link it to prefetch. So here we have an executable. We have our MFT entry number and sequence number from our Amcache data. We also can then go reference our fallout, in this example, prefetch file, which is nice because now we have run counter, we have our volume information, and when it was created in the serial numbers, you could see all the individual run times depending on your operating system. But then we can also cross-reference that back to our MFT entry number and sequence number, which is the same path here. Again, X-Ways showing us the file record template, so we can say, oh, okay, that is the same ID and the use deletion count. That's the terms that X-Ways uses for what we've been talking about when it comes to entry number and sequence number. So we can go from basically one line of entry, one point of entry, back into fetch, and then we have all this other nice data to be able to add to and pivot around as we need to, depending on what we find. So here we have our app.compat cache, and this is more just a list of programs that ran and the last modified time of the executable. It is not the time the executable was run. That isn't tracked in those systems. It's the last modified time of the binary from the file system. So here you could see if we started with app.compat cache, we could then pivot into Amcache. You can see that the last modified timestamps are lining up. We can see that the path is lining up. But as you've seen, now we have, when we go from app.compat cache, which is generally a low volume of information, basically the position in the cache, the full path, and then our modified time, and depending on the operating system, we would also be able to tell you whether or not that binary was executed. We could then go into Amcache, pivot, and we could see all the other bits of information that we have. So app.compat cache doesn't track hash or anything like that. We have no SHA, we have no MD5 or anything like that. But as you've seen, if we have these kind of information, we can now get to our SHA-1 and be able to do all the nice things we could do with a good hash value. So the next step I want to talk about, the next chunk of the presentation, is I want to get into some testing, talk about some metrics, because when I started looking at this and doing some testing, right, and we'll get into the tool output and how they work and what platforms, but it was interesting to me when we look at a Hive as a whole, and then we get into, well, tell me about the program, the files that were put on a system from installers versus programs that ran outside of, coming from, and being related back to an installer. So the next thing we want to talk about before we get into the results of the testing is just some metrics. So this is an example. So on this Hive, let me just step back. So this is 21.2 meg Hive from a busy Windows 10 machine, a lot of things installed, a lot of usage, things like that. So if we take our Hive as a whole, and we basically, if you remember back to our file bucket, we have two types. We have the unassociated and the associated. So what I did was ran one of the parsers and then took my output files, grouped them, pulled out all the stuff, and then counted basically by unique extensions. So you can see in the bottom entry, the associated ones, we have a lot of DLLs, a lot of executables, and so on. But then when we get to the top, things are much less, where we have just three: exe, temp extension, and SCR. So we can do all these different kind of things to get a better understanding of what got where and what kind of extensions are being put on systems, and you can see how much less data already just by looking at the two file lists, the numbers. We have 22,000 DLLs and 2,400 executables, but if we only look at stuff that isn't associated, now we've already just reduced our work down to 722 executables and then 32 other, so to speak. So amcache.py is a tool. There's a lot of tools by Willie. He has to process registry hives and registry keys. So this is a Python script, and basically it will extract all of the entries out of the program's keys and file entries keys and blend them together, and the default is going to be output to the screen. You can see the usage there. It's very simple to use, and you will get pipe delimited format coming out to standard out. If we redirect it, you can redirect it to a file. Now, one of the things that I ran into when I ran this against my Hive, I initially had 52,000 rows of data. When I opened it up in an editor, every other line was blank. So I reached out to Willie, and he immediately figured out what it was, and it had something to do with Windows when you redirect output, and he fixed it within a few minutes. And so now we don't have to worry about deduping if you're running this on a Windows system. But basically, the last line there is we end up with 26,131 rows of data. There's a sample of what a particular part of that file looks like. You can see we've got the full path, we've got our SHA, the size if it's available, the description if it's available, and then first run date, created timestamps, all the different things. Now there's a ton more that goes out to the right, but I don't have it all in there so you're going to get a lot more than what you're seeing is what I'm saying. But that's just a sample of the kind of data that you'll get. And then it's just some runtime metrics and whatnot at the top. So this works very well. It's cross-platform, which is nice. If you're on the Linux side, you could use it there. On the Windows side, it doesn't matter. And you could do, once you have the data processed, you can do whatever else you want with it. Pull it into another tool, process it again with any other tool, since it's just plain CSV data. So Amcache Parser was my attempt at an Amcache Parser, and it's written in C#. So right now I haven't done a lot of testing on Mono or .NET Core, but as .NET Core matures, I will check and see that things compile and work on Linux and Mac and all those kind of things as well. All the command line stuff, I don't see a reason why it wouldn't. So for right now, it's a Windows thing, it's a Windows tool, but it has a couple extra features in that by default, and we were talking about this as we've gone through our whole presentation, I don't want to look at everything by default if I can help it. So if you just run it with the minimum options, you're only going to get out the unassociated file entries, which is our stuff that we can't tie back to some type of installer. So that would zip us down from, say, 20,000 down to 800 potential entries. And then from there we can do some other things which we'll talk about in one moment. So if you needed all of the other detail, you certainly have access to it, and there's just a command line switch that you can use, and as you'll see, we'll do an example. If you use that switch, you'll get a list of all the programs, and then you'll get a list of all the files associated with those programs. So now you have essentially, if you use the I switch, you get 3 buckets of data. You get your unassociated, you get your associated, and then you get the programs that those associated file entries they tie back to. And then the last feature that Amcache Parser has is the ability to whitelist or blacklist based on SHA. So we'll see examples of that and how it could be further used beyond the built-in deduplication of stuff not associated with programs. We can further reduce what we're looking for, either to exclude trusted binaries or look for only known bad binaries. So that would be the whitelisting or the blacklisting. So output is tab delimited, and it will automatically create the TSV files into the directory that's specified by the S switch. So you can see some examples there. It's very straightforward. You just have your Hive, and you give it a directory, and it will do its thing. So again, at the top we have some metrics. At the bottom you can see it's the same Hive, but we've only extracted out 754 rows. So this is again just a subset of what you'll get in that CSV file. If it's CSV, it's tab separated, so if you pull it into Excel, the easiest way to do it is to open Excel and then start a blank worksheet, go to the data, import text. You'll have to change the extension, and then all you need to do is say, my data has headers, hit finish, tell it where it goes, and it will do the rest. It'll detect the tabs and everything else. It's very straightforward to do. So you can see here we've got the dates and times. Our last write timestamps will get included in this for the volume, the file ID, and so on. And one particular thing in mind that you can see is we have our full path again, but for the SHAs for mine, I have already stripped off those extra 4 zeros. So those are going to be gone, and all the dates, if there is no date to give you, it's blank. So it's not going to be like epoch or January 1st, 1601 or anything like that. If it's nothing, if it's 0, it will just be a blank. And for the dates that we do have, you could see we could do their time zone. We have our time zone, and it's set in a standardized format. So sorting and all the other kind of stuff would work. I also pull out the file extension separate, so that's where I was able to take and quickly count and figure out all the metrics that we already talked about. And then you see we have our MFT entry number and sequence number that we're pulling out of that, the file entry key. So as I mentioned, by default, if you just run it and you'd use the minimum values, you get one single file. I is the one that we would want to use, and that is going to give us the 3 files that I mentioned previously. So we've already talked about what we see in the unassociated, which would be this stuff. So if we go into the other 2 files, this is the kind of things that we would be able to now to talk about. So at the top, that would be our programs. So this is a listing of all the keys and the values that come from underneath the program subkeys. And you can see we've got our ID, we've got our timestamps. That would be from the program ID registry key, and then the various values that we've already seen. If we go down, the bottom part is our unassociated, and you're going to see more or less the same kind of stuff that you already saw in the previous example with unassociated, except you could see highlighted I have the program ID, and then in the associated programs we have the same ones grouped, and then now we could basically say, okay, Fallout, put these binaries, these files on the box. So if you wanted to go back and group it by installer, you could certainly do that, and this would be just one means that you could do it if you needed to do that kind of correlation. So the last part that we want to talk about, there's two parts to we want to talk about whitelisting, we want to talk about blacklisting and the differences. So after I ran just the normal run, we get the unassociated program entries, or excuse me, file entries. And so this is a partial list of what we would have in there. And we're interested primarily in the full path and the SHA at this point. And you can see that a lot of the ones that are here are stuff that is running out of the Windows directory. So in some cases, you may not want to know whether trusted Microsoft binaries ran because it's just adding more noise. Do you want to know if somebody ran regedit? Do you want to know if the trusted installer ran, for example, at the top there? Maybe you do, maybe you don't. Is CMD interesting to you? Maybe it is if it's the secretary's machine, or PowerShell, like why is that running on these other places? But in some cases, you may be able to determine that these executables, we don't want to know about these. We want to further reduce down what we have to look at initially. So based on that, we could go into and look at the SHA, and then you copying out the SHA right from the column, we can create a whitelist, which as Amcache Parser is working, if it sees anything in the whitelist, it will just drop it from the output, and you won't even have to see it in there. So for example, if we just take this subset of binaries, this isn't going to be everything that we're going to whitelist just to highlight the percentages, but this is just part of what we say, hey, we trust these. I'm not interested if these ever run, so don't show them to me, basically. So we copy those out. All they have to be is in a plain text file, one SHA on a line. It doesn't need any kind of prefix or anything else. And after you save that file out to somewhere, all you need to do is supply that path to the W switch, and Amcache Parser will ingest all those hives and, or excuse me, all those SHAs, and then compare them against everything that's found in the hive. So if we do that, you could see previous, when we run Amcache Parser, we have 25,845 entries, and again, there's our 754. But when we whitelist, now you can see I had 187 in my whitelist file for this example, and you can see we dropped that down to 532, and we cut basically in half the number of things that you'll have to look at in your initial triage. Okay, so it could be very beneficial if you're coming from, for example, a gold image, some other type of standard. We know everything on this system is good. Well, you could take all those SHAs off of your gold image or a known good machine and then put them in a file and quickly say, I don't even want to know when those run. Did anything run outside of the stuff that we've put on this box intentionally? And you might get down to 3 things or 1 thing, who knows. But that's why you would want a whitelist, is to take and eliminate all the known goods to get down to the unknowns. So on the opposite side of that, maybe we found some malware or something in our systems, and we want to now find and determine where they are everywhere else. So if we take those particular files, the ones that we have deemed are bad based on however we got to that conclusion, again, this is just an example of some things we're interested in. So we have, like, we see some things running out of the temp directory. So for XWFIM or WFA, maybe we know what those are, maybe we don't. But again, we can just take those SHA values, put them in this case, a blacklist file, and when we supply that path to the B switch, then it will, AmcacheParser will do the opposite of what we saw with the whitelisting. It's only going to include in the output things that where it found a matching SHA value. So, and this is just another example of the usage. You can see it's everything we saw before. This time now we only have extracted out 16 based on our blacklisting. Okay, so it's really a quick way if you had a bunch of Amcache hives from however you decided to collect them, and just to sweep across and say what other systems were these bad executables also found to have been executed on. So just to wrap up some of the whitelisting and blacklisting, so that it's based on the SHA. That's pretty straightforward. It's the only hash in there. But because if things are running from different places, it might have the same SHA, but it could have a completely different path. And so because of that, I have 100 SHAs in my blacklist. I only see 80 or 140. You're going to see it's not going to match every time because of the paths, right? Every time it runs from somewhere, you'll get a new file entry record, and it's going to, the SHA is the same, and that's what we're keying all this off of. So you have to keep that in mind. Just have an understanding of where that data is coming from. So that's what the bottom part's basically saying. If that happens, then you get double, or however many times it ran from different places, all those extra things that we've been able to look at and discuss. So this is a list of the other resources that I've used in the past and that what we've talked about. So at the top you have several links to the Swift Forensics blog. You've got a link to Willie's source code, and then my initial post on the Amcache parser, and then the source code itself for the Amcache parser. So it's all C#. If you wanted to just tie in the core logic, you could take just the parser and then put it into any other program you want. You don't have to rely on the executable, right? So if you had the means to take just the processing part, you could put that into any other system that understands how to deal with .NET code. Primarily, PowerShell comes to mind, so it can natively run C# code. Just tie that into PowerShell. There's a bunch of really nifty frameworks out there that are starting to do that stuff. So this is a really good reference if you want to dive deeper into and have an understanding of the tools and an understanding of how the tools are, like particularly Amcache Parser is doing the, okay, look at the programs, then go back and find this, here's our ones that don't match, and so on and so forth. So we have a little bit of time, so what I want to do is exit out of here and just do a quick demo. So in here I've got two files. I've got a Hive file and I've got the Amcache Parser. So if I just run the Amcache Parser by itself, you'll get usage. So basically this is telling us we need an F for our file, and we could just do our amcache.hive, and then we need an S switch, so we could say -S, and if we just do dot, it's going to dump it out to the current directory. It processes the Hive, and we're done. So this is the same Hive that we've been talking about. So you can see now if I go back to our directory here, we've got our two files we started with and then our new file. So if I open that up and then bring this over, hopefully everybody can see that okay. It's small, I know, but basically we have our program name unassociated, we've got our ID, whatever ID it came from that's in that doesn't mean that it exists. That's just what was in that particular value for this particular file ID. Okay, so you can see then it just keeps drilling down into timestamps and so on and so forth. To look at it in a text editor is a little bit weird because it's tab separated, so your columns don't line up. This is what we could then very easily pull into Excel, as I talked about earlier, and everything would line up, and you could start doing all the normal stuff with sorting and filtering and doing all the things that you're trying to do to narrow down into things. So if I close this, or just minimize that for now, go back to this, and I go up, I'll just demonstrate the I switch. So everything's the same. All I'm going to do is throw the I switch on there now. And then, well, for example, I'll throw one more on there too, MP. So that will basically, for 64-bit timestamps, we have like millionths of a second resolution. If you needed that level of granularity, this switch would give it to you. So if we run that now, it's basically going to do all of its normal thing. But you can see we have our unassociated from our first run. So if I delete that, now we get our unassociated again, same data, but we have our program entries and our associated file entries here. And just by looking at the file sizes, you could see 9 meg is just stuff that we could track back to an installer or otherwise. So right away we've already dropped that, and we've got us down to 305K that we have to look at. So I won't open up the associated ones, but I'll open up the program entries just to show you the different values. You can see we've got our program ID and a lot of the same stuff we already saw that just keeps going out, all the different things that we talked about, and then of course a couple more fields that may be interesting: the install source, the language code. There's a couple install dates that are epoch, so you could pull those in and start doing other cross-referencing and correlation around those if you needed to. I don't think, well, I could do, let me pull this file open, the unassociated. And what I want to show you is right here. So if I could, let's see if I could just make that bigger. That's the easy way. So now you can see that I threw that --MP on there, and you can see we've got much better with full timestamp resolution now for all of our 64-bit timestamps, right? So it's not just down to the second, it's down to the millionth of a second. So if you need that, you can. It's all in there, no problem. If I go back to our PowerPoint, flip. So that's it. I wanted to leave some time for questions. I've seen the one question that Kevin asked about the APIs or tools which could do some anti-forensics. That'd be an interesting experiment. I haven't done it. I could certainly look into it to see if there isn't anything that could be done. I'd be interested to see if Amcache is locked all the time. If it is, it would make it a little bit more difficult, but certainly not impossible. So if anybody has any questions, throw them out there. Otherwise, we'll give it a couple of minutes, and I will turn the time back over to Carol, and we will wrap up the webinar. So a few more minutes. If anybody has one, we'll get it answered. And I'm easy enough to find and contact. Hit me up on Twitter or email or anything else. Happy to talk about it. If you have any must-have features or you have some great new idea, please let me know, and I will do my best to get it in there as soon as possible. And I think the community as a whole benefits for those kind of things, getting as much eyes on these things as possible. We can come up with better tools and techniques to find new and interesting artifacts. So I don't see any new questions coming in, so I will turn it back over to Carol, and we'll wrap it up. I thank you for your time, and again, please, if anybody has any questions, hit me up. I'm more than happy to answer. Thank you very much.
All right, thank you so much, Eric, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, you can visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.